On the IDA-1S, we have a real simple setup. All we need to do is hit flow on the test. We would put in any patient name if we had any. We're just going to skip through. We're going to connect the pump as it requests. We already have, I just showed you that. And the most important thing here is notice the red bar. That tells you the device is not primed. This is where the syringe comes in. So as I press on the syringe, you'll notice that the blue bar, or the red bar, shows up as a blue bar. There it goes. And once it is completely blue, you're actually ready to go. Don't forget to change your switch to close the syringe and open your infusion device. So at this point, all we need to do now, I'm going to start my infusion device, and I'm going to start the test at the same time. Start, and start. You should see some numbers coming up shortly. There they are. That lets us know the device is currently functioning properly.
Meet the next generation electrosurgical analyzer, the Fluke Biomedical QA-ES3. This all-in-one analyzer offers improved functionality, accuracy, and ease of use over its predecessor, the QA-ES2. The QA-ES3 collects all measurements including vessel sealing, high-frequency HF leakage, contact quality monitor, and output power distribution in single or continuous mode. It also measures cut and coag waveforms with either monopolar or bipolar outputs. The automatic power distribution feature allows automatic measurement of power, current, peak-to-peak voltage, closed load only, and crest factor. The addition of automation speeds up testing and helps reduce human error.
The ProSim Spotlights SpO2 Functional Tester, the newest member of the ProSim family. The scenario that we're going to talk about today is one that happens every day in the medical facility or hospital, where you get a call from the clinical unit. The oximeter is not working on some medical device. So you grab your Spotlight and you go up to the clinical unit. In this case, we find the device turned on. It's a defibrillator. And we will turn on our Spotlight SpO2 functional tester, wait for it to go through its self-check, and we will then connect the oximeter sensor from the medical device, and we'll watch this bar down at the bottom. It's called the signal strength bar, and you can see that it has a good signal, and you will begin to see the display on the screen of the defibrillator. Now, testing this functionally really quickly is just a 4-button push. We're going to go to our custom setup and go to Custom 3, which is programmed for a patient with a high heart rate and a high O2 sat. You can see it sets off the high limit alarms, which is exactly what we want it to do. We'll watch till the oximeter reading and the heart rate settle. And then we'll move to Custom 2, which is a normal patient. We want to let the alarms continue to sound because the normal conditions will let them silence on their own, an important part of the functional test. Again, waiting for those to settle. And then we'll simply push one more time for our hypotensive patient with a low O2 saturation, low perfusion. And you'll see the alarms will sound again, this time on the low end. And again, we'll wait for the readings to settle. And we'll push one more time to get back to a more normal reading so the alarms will quiet once more. And there we are. You've tested 90% of it in right around 30 seconds. The SpO2 functional tester, Spotlight, the newest member of the ProSim. Patient monitor testing can be quicker and easier than ever before with ProSim 8 from Fluke Biomedical. We're going to do a patient monitor test, and we're going to try and do a complete but quick test of this patient monitor. The parameters we're going to test are ECG rate, respiratory rate, invasive blood pressure, channel 1. We're going to do a cuff blood pressure and IBP measurement and oximetry. We're going to try and get all of this testing done in under 5 minutes. As you can see, there's a digital clock shown in the lower left-hand corner of the patient monitor display. So you can be your own judge as to whether we can get through this test within 5 minutes or not. So as I begin the test, we are already connected to the device under test. All of the connections have been made ahead of time, including the NIBP cuff. And we are going to zero our invasive blood pressure transducers on the patient monitor at the very first step of what we do, followed by a selection of a simulation of all coordinated patient parameters. We'll do hypertensive first, followed by normal, followed by hypotensive. in order to assess whether we have a performing patient monitor. We will compare the displayed values on the ProSim 8 against what's displayed on the patient monitor at each set of simulated parameters. Are you ready? Let's begin now. First thing I'm going to do is 0P1. It is at 0. And now what I'm going to do is pick hypertensive. And the simulation will already begin, so I'm going to start a cuff blood pressure reading. In this case, we're looking for an ECG rate of 130 beats per minute, respiratory rate of 40. We're looking for an invasive blood pressure display of 200 over 150. We're looking for NIBP of 200 over 150 with a mean of 167, and an SpO2 reading of 90. And it looks to me like we've got all of those on the patient monitor. 130, invasive blood pressure 198 over 149 with a mean of 167, and we have 90 O2 sat and 197 over 142 with a mean of 165 on the cuff. Let's move to normal. The normal simulation includes heart rate, ECG rate of 60 beats per minute, a respiratory rate of 20 breaths per minute, invasive blood pressure of 120 over 80, and a cuff blood pressure of 120 over 80 with a mean of 93, and SpO2 at 100% O2 sat. As you can see, the patient monitor is already displaying 60 beats per minute for heart rate. It's gotten 119 over 79 with a mean of 93 for invasive blood pressure. And the cuff is making its measurement now for the O2 sat, or for the NIBP reading. O2 sat is 100%. There we go, 121 over 77 versus 120 over 80, pretty good. We'll go to hypotensive now and start another cuff measurement. We're looking for an ECG rate of 40 beats per minute, respiratory rate of 15 breaths per minute, and invasive blood pressure measurement of 50 over 20, and cuff blood pressure of 50 over 20 with a mean of 30, and an O2 sat of 97%. You can see that the ECG rate on the monitor is already 40. Our invasive blood pressure is 50 over 19, very close to 50 over 20. Our cuff is working on getting its measurement, and the O2 sat is 97, right on with what we asked for, what we're simulating. We started at 18:55 and 44 or 45 seconds, and we're going to finish very shortly here. Done. And we have good values. As you can see, it is possible to do a complete, quick assessment of patient monitor performance using ProSim 8 and front panel controls in under 5 minutes.
1. Fill your soap tray. When filling your soap tray, use the same cleaning agent for cleaning the ultrasound probe. You can also use tap water. Step 2. Connect equipment. Start by plugging your transducer adapter into one of the two ports on the top of the ULT 2020. You can use either port. Next, plug the ultrasound transducer into the adapter. The adapter should click into place. Look in your ultrasound transducer manual for OEM recommendations on connecting your transducer. Once that is attached, plug your dual-prong conductivity probe into the second port on the top of the ULT 2020. You can use either port. Now all parts should be fully connected. This includes the ULT 2020, dual-prong conductivity probe, transducer adapter, and ultrasound transducer. Step 3. Insert probes into the soap tray. Start by placing your dual-prong conductivity probe on the edge of the soap tray. Ensure the tips are fully inserted into the cleaning solution. Next, place your ultrasound probe into the soap tray. Step 4. Turn on the ULT 2020. Press the button marked power on the ULT 2020. The screen should light up. If not, check to ensure the tester either has batteries or is powered by an AC adapter. Once on, simply press Full Test to begin the test. The machine will do all the work, you just need to wait for the results. When finished, Pass or Fail will appear on the screen, indicating your results. If a printer is attached, the results will print off in detail, along with a Pass or Fail. Repeat this process for all ultrasound transducers.